Hello students, welcome back to Learn 24. In this video, let's discuss about the solubility. First of all, I will give you a definition to the solubility. Solubility is the maximum amount of substance or the solute that dissolve in a solvent at a specified temperature. That means, just imagine I have a glass of water with me and I added 1 spoon of sugar to it and I dissolved it very well. Again, I added 1 more spoon of sugar to it and it also dissolved very well. Again, I took 1 more spoon of sugar and I dissolved. But what happened? It didn't dissolve. It settled down into the bottom of that water. This is the solubility. Maximum amount of solute that can dissolve in a solvent is the solubility of that solution. Maximum amount of solute that can dissolve in a solvent is the solubility. Now, the solubility depends on 3 factors. That is the composition of solute and solvent, temperature and pressure. I am going to explain this in the coming topics, right? Okay. As I told you, when I keep on adding the sugar to the water, it was not dissolving. It kept on depositing on the bottom of that water. It's the saturated condition where no more solute can dissolve. That is a saturated condition. No more solute can dissolve in that particular solvent. It's saturated condition and the solution is called the saturated solution. And the condition before saturation is called the unsaturated condition, where more solute can dissolve is the unsaturated condition, or the solution is called unsaturated solution. You clear about saturation and unsaturation? Alright, now let's discuss how these solids are soluble in liquid. That is the solubility of solid in liquid. Now, all the solute will not dissolve in all the solvents. The polar solutes only dissolves in polar solvents. And similarly, non-polar solutes only dissolve in non-polar solvents. And polar solutes will never dissolve in non-polar solvents. Likewise, non-polar solutes will never dissolve in polar solvents. For example, NaCl and sugar will dissolve in water, right? Because both are polar in nature. So, the solute will dissolve in solvent. And naphthalene and anthracene will dissolve in benzene because both are non-polar in nature. And NaCl and sugar will not dissolve in benzene because they are polar and non-polar. Like naphthalene and anthracene will not never dissolve in water because they are polar and non-polar, right? So, the polar solutes only dissolve in polar solvents. Non-polar solutes will only dissolve in non-polar solvents. Now, as I told you, the solution is formed by dissolving the solute in solvent. Solute plus solvent will give a solution, and this process is called dissolution. And the solute particles that are dissolved will collide with each other and they separate from the solution and becomes solute and solvent. The solute particle will collide with each other and they will separate from the solution and forms solute and solvent, and this process is called the crystallization. It's a reverse reaction, right? It's a dissolution and crystallization. Hope you all are clear with that. Now, let's discuss the effect of temperature. That was the second factor, right? Temperature. Let's discuss the effect of temperature. To discuss this topic, we have to know about two terms, that is endothermic and exothermic. If the reaction is taking place by gaining the temperature, that reaction is called the endothermic reaction. They need temperature to take place, that reaction is endothermic. The temperature is just entering as endothermic. And what is exothermic? Exothermic means they liberate temperature in order to take place that reaction. They liberate the temperature is exothermic. The temperature is just exiting, that is exothermic. Just remember by that points, if heat is entering, they gain temperature and reaction is taking place, that is endothermic. If the temperature is exiting from that solution mixture, and that is exothermic. Now let's discuss if dissolution process is the formation of solution, right? If dissolution process is endothermic, reaction takes place by gaining the temperature, is endothermic, where the delta H solution will be greater than 0. If dissolution is endothermic, solubility increases with the rise in temperature. That means they are already using the temperature to take place the reaction. They are gaining the temperature. What happens if we give more temperature to them? If we raise the temperature, the solubility increases. If we raise the temperature, solubility increases. If the dissolution is endothermic, they need more temperature, so the solubility will be in high. So if dissolution is exothermic, they are liberating the temperature. What happens if we give more temperature? They will get angry, right? They are already exiting the temperature, and if we give more temperature, the solubility will decrease. Solubility will decrease with the rise in temperature. So in order to increase the solubility, what we have to do? We have to lower the temperature. If the dissolution is exothermic, we have to lower the temperature, hence the solubility will be high. Clear about the effect of temperature? Alright, now the third factor was the pressure. Pressure has no effect on this because the solid and liquid are already in a compressed form. So the pressure has no effect on this type of solubility. Now let's discuss how these gases are soluble in liquid. That is the solubility of gas in a liquid. Now the pressure plays an important role in this type of solubility because I am using gas as the solute, hence the pressure plays an important role. Now let's have a look on this image. These are the gas molecules which are less soluble in water. The only few molecules are soluble in this water, right? Yes. This is the piston. Now I am applying some pressure. Using this piston. What happened? Now the solubility just increased. The gas molecule which are soluble in this water just increased. So I can say the solubility increases with the increase in pressure. When I applied pressure, the solubility just increased. So solubility will increase with the increase in pressure. This is what we are seeing in the soft drinks. In order to make the soda, I have to mix the water with the carbon dioxide and I have to apply the pressure and close the cap. Now I got the soda water. I have to apply the pressure in order to dissolve that carbon dioxide in that water. Now I got soda. What happens if I remove that cap? The pressure just lowers. Hence the soluble carbon dioxide will pop up like bubbles and the carbon dioxide will come up. Hence when pressure decreases, the solubility also decreases and carbon dioxide came up. Right? When pressure increases, solubility also increases. This is well explained by a law called Henry's law. Henry's law states that solubility of a gas in liquid is directly proportional to the partial pressure of gas present above that solution. It's just simple. The pressure, the increase the pressure, solubility also increases. or the pressure is just directly proportional to the mole fraction of that gas. Pressure is directly proportional to mole fraction of that gas. In order to remove this proportionality sign, I have to add a constant called Kh. Kh is the Henry's law constant. Kh is what? Henry's law constant. P is equal to Henry's law constant into mole fraction of that gas. This is the Henry's law equation. Pressure is equal to Henry's law constant into mole fraction of that gas. Now let's discuss the graph of the Henry's law. I took partial pressure in the y-axis and mole fraction in the x-axis. I got a straight line starting from 0. And the slope of this straight line is Kh. Kh is the slope of this straight line. This is the graph of Henry's law. This is the case when I added one gas. This is the case when I added one solute or one type of gas. Now I have to add three different types of gases. Those are A, B and C. I added three solutes A, B and C. These three different gases have three different Kh values, as you can see. They have three different Kh values. C have the highest value of Kh and A has the lowest value of Kh, as you can see. And now let's discuss about the solubility of these three different gases. Now, I applied this much pressure. And A was soluble this much. A dissolved this much. But B dissolved only this much. And what about C? C only dissolved this much, right? What was the conclusion that I can see to this? By increasing the value of Kh, solubility decreases. Whenever the value of Kh just increases, the solubility decreases. Here C have the highest value of Kh and the solubility of C is only this much. So I can say the solubility decreases with increase in the value of Kh. Solubility decreases with the increase in the value of Kh. I hope you are clear with that. Next point is the solubility just increases with a decrease in temperature. Solubility increases with a decrease in temperature. I will give you a point to remember that. Now, we all drink these soft drinks, right? That we kept in the cold condition. Always will keep these soft drinks in the cold condition. So, the solubility just increases with the decrease in temperature. If we decrease the temperature, solubility just increases. This is the solubility and the Henry's law. Now let's discuss some of the applications of Henry's law. As the pressure increases, solubility also increases. Keeping this in mind, let's discuss the applications. First point, in the production of carbonated beverages. We already discussed about this, right? Going to the next point, in deep sea diving. The scuba divers or the divers always carry a cylinder bag to them, right? That cylinder carries oxygen and nitrogen. In the deep sea, the pressure is very high compared to the surface water. As the pressure increases, solubility also increases. The deeper a diver goes underwater, higher the pressure, more will be the solubility of gases in their blood. As the pressure increases, nitrogen gas will go to the blood and tissues. And it will not create any problem until the diver is under the water. As the diver rise to the surface of water, the nitrogen gas dissolved will bubble up from the body, and it's a very painful condition, and that condition is known as bends. It's a very painful condition. It damages to the nervous system and all. And in order to avoid these conditions, divers always moves very slowly upwards or in a stepwise manner. They rise very slowly to the surface of water. And also, in order to decrease the solubility of this nitrogen gas, we can also add some of the helium gas to the cylinder. Here is the application of Henry's law. As the pressure increases, solubility also increases. Next topic, in the function of lungs. As we all know, we inhale oxygen, right? And it goes to the lungs. And here the pressure is very high and oxygen will dissolve with the hemoglobin in the blood and forms oxyhemoglobin. And this oxyhemoglobin will travel to the blood vessels and goes to different organs, right? Here the pressure will be very low. So the oxygen will depart from this hemoglobin and forms deoxyhemoglobin. Here also we see the application of Henry's law, right? As the pressure increases, solubility increases. Next point, climbers living at high altitudes. In the high altitudes, the pressure will be very low, so do the oxygen. The people living over there cannot get sufficient air to breathe, sufficient oxygen to breathe. So they feel very tired and weakened. This condition is known as anoxia. They cannot memorize so well. This condition is known as anoxia. And these are the applications of Henry's law. As the pressure increases, solubility also increases. We studied about the solubilities, right? In the next video, we are going to study about the vapor pressure of liquid solutions. See you friends in the next video. Bye bye.